Hello, in this video we are going to explore graphing equations in our y equals and then adjusting the window to view those equations graphed. So let's go ahead and go to y equals and let's enter in two functions. Our first one will be 15x plus 60, and then in y2 let's go ahead and put 20x plus 100. Now notice we've got some steep slopes with some higher y-intercepts, so when I press my graph button, I'm not going to view or get a good picture of my two functions. I can't really compare their slopes very well. I can't see anything other than their x-intercept. So I can adjust my window by pressing window. If you see, it's currently in standard window, which has x and y minimums at -10 and the x and y maximums at +10. So let's go ahead and change our x min to 0. And let's see what happens when I put my x maximum at 30. Because a lot of times our x is talking about time or in seconds or things like that, and so we don't necessarily, in a lot of problem situations, need to have a negative x value. But then if I were to go to my y minimum, let's go ahead and also start it at 0, and since I have such high y-intercepts, let's set the max to 500. Now as I've set these maximums, another thing that I can change are my scales, and since I have 30 spaces going along my x axis, I could go ahead and make a scale of 2 so that my tick marks on my graph will be two numbers apart. And then for my y scale, I'm going to leave that at 1 just to show you what happens if you don't change the scale at first. So let's go ahead and press graph. And at first glance we see that we have a lot prettier of a picture of these two functions. Notice because I changed my scale along my x axis, I have tick marks that are 2 apart, but since I did not change my scale on my y-axis, I've got a solid thick black line. So if I were to go back in and change my y-scale to, let's say, 10, let's see what happens when I do it to 10. Okay, so I've got some tick marks that are farther apart. I could also change it to 20 to get another nice pretty view of our graphs. So now let's go ahead and explore the trace function. The trace button is right next to your graph button on your calculator. If we press trace, it automatically takes us to our y1 function, but I could cursor up and down to toggle between the two. And then if I cursor left and right, that's where I'm going to be exploring my input and outputs for this function. But notice I don't have very pretty values for my x and my y. So we have some friendly windows that we can use to help make our trace a more valuable option in the classroom. Those functions can be found in your zoom button, and there's two of them. Zoom integer is your 8th option, and the one that I'm going to be showing you in this video is zoom decimal. So let's cursor down to zoom decimal, and notice it reformats my window. And so it's not necessarily a good picture of the two functions graphed, but this time when I press trace and I start to toggle to the right, my x is increasing a tenth at a time. So I have some meaningful data that I could be gathering from these functions in a real life scenario. And again, if I were to toggle up to my second function, the same thing is true. And so the only difference about zoom integer is that instead of moving a tenth at a time, it would move one integer at a time. So -2 to -1, 0, and so on. So I hope that you will now be able to adjust your window to better view your graphs that you have in your y equals function, and then also use the trace button to meet the needs of your students in your classroom.